In this paper, we propose HDR hexplane, a method for synthesizing HDR images from dynamically exposed scenes with varying exposures. Hexplane is an excellent representation for dynamic 3D scenes. It encodes scene information using 6 2D planes and employs MLP, multi-layer perceptron, to predict the final color and volumetric density. Hexplane can render high-quality dynamic novel views under natural lighting and obtain depth information of the scene. However, not all scenes can be photographed with clear scene information with a single exposure coefficient. At this time, hexplane is unable to perform correct learning on the scene, thus synthesizing a high-quality HDR image, while simultaneously capturing information from the light and dark parts of the scene is very important. To address the above issues, we propose HDR hexplane, which solves the problem of synthesizing new HDR perspectives in dynamic scenes. By inputting dynamic scene images from single or multiple cameras with different exposures, we can effectively synthesize novel views with different exposures, as well as depth and corresponding HDR images. The framework of the model is shown in the following figure. For a scene, we project corresponding rays and sample them to obtain the coordinates, direction, and time of each point in space. Then, we use hexplane to calculate its spatial irradiance and volume density. Meanwhile, for each index, we use the exposure mapping module to calculate its exposure value. Firstly, we use an embedding layer to calculate the exposure coefficient, and then use an MLP to adjust the embedding to obtain the final logarithmic exposure value. After multiplying the logarithmic exposure value and spatial irradiance, the color C is obtained through the camera response function, and the LDR image is obtained through the volume rendering formula. After combining irradiance and density, the corresponding HDR image can be rendered. The LDR color values and real color images are supervised for training the entire model through a function. In addition, our dynamic scene learning representation can also be replaced by other modules such as TNUVOX. Our model is capable of rendering new perspectives of dynamic scenes at arbitrary exposure levels. Compared to other models, we offer superior rendering quality.